So this is a lesson that I normally run for Higher Education Day, which is where we get employers and mostly universities and education providers, and you guys can go around and talk to them. Every lesson that you have that day is a subject lesson that's devoted to university, careers, your next steps in education. It's a really, really useful day. And so this lesson is the lesson that I run there. It's focused around those things, mostly higher education, to be honest. Because when you're doing physics, that's kind of the main track that you would take. And I'll talk about the options that are available in there today. I hope that you can use this video to kind of inform your thinking. Very few people are blessed with that, absolute knowledge of what they want to do when they grow up. Also, as physicists, engineers, scientists, you're vastly employable and you're not really narrowing any options down. But again, that's not a bad thing. It's better than being limited. It means that over time, things might slowly fall into place and you'll find something that you really love. To boot, I actually love this session because I really enjoy talking about this kind of stuff. We spend so long stuck in the A-level world. This is where we actually get to look at where this might be useful and to inform you and give some kind of idea about what you might do next. And that can be a really, really crucial motivator as well. We're looking at this when you're kind of 16, 17, you've got your massive exams when you're 18 and then you leave us. This can really help motivate you through that final year to absolutely push yourself to achieve great things. I'm not saying it'll be this presentation that does that, by the way, that's the wrong way to say, but more that having some kind of idea of where you want to go and what you want to do, or at least what it might be like on your way, even if you don't know where it's going to end up. Because to be honest, even I don't know that. So let's have a look. So this session is usually more of a discussion, and I open with this question. Imagine that you went on to get a degree or a degree apprenticeship, some qualification in physics, engineering, STEM. What jobs would you be qualified to do? I give people about 3 or 4 minutes to think about this, and normally what comes out is, engineer, physicist. What is a physicist? But then I start to probe and I start to say, could you be a lawyer? Could you be a patent attorney? Einstein was a patent attorney. Could you be a medical professional? Absolutely. A pilot? Could you work in a shop? Could you be an artist, a philosopher? And actually, we start to think that you can do literally any job if you have a good qualification in physics, engineering, in STEM. We'll look today at the skills and the qualities that you pick up, the professional skills, transferable qualities that you pick up from studying at this high level. Physics, maths, engineering, they are widely regarded as some of the most technically challenging degrees out there. For good reason they are. The reward for that is this vast, almost endless array, and I always challenge people to try and come up with a job that we couldn't do as professional physicists or engineers or mathematicians, and I am yet to find one. And you know how much students like to play around and try and prove me wrong. They've still not managed to. Just to put that into perspective, I was thinking about graduates that I know. So these are people I went to university with, my friends now that have STEM degrees. And they do literally like a massive diverse variety of things. I know people that work in geophysics, doing oil prospecting, doing uranium prospecting, mining, stuff like that. People who work for the Ordnance Survey, that is a really cool data handling job. Financial services, did you know that finance is the biggest employer of STEM professionals? Don't go and get a finance degree, get a physics degree. It's better, you will be better than anyone who gets an MA in finance, I guarantee it. If you want to, you can go into research. Loads of people love the idea of being a professional physics scholar. My old lab partner from second year is a fusion PhD graduate, and she worked at ITER in France. If you don't know what ITER is, that is the international collaboration on fusion energy. Go look it up, it's so cool. Another friend of mine got to work at the Mauna Kea telescopes in Hawaii, the very large array there, and post it on Instagram, and I was really, really jealous of them. I did know some engineers, some process engineers, some chemical engineers. God forbid, I did also know some students who did chemistry. They go to work at Shell, BP again, United Utilities, people who run the water for the Northwest. They're a massive local employer for STEM graduates. Airbus has a big presence in the UK along with all of their subsidiaries. One of my best mates works at Airbus. He writes the code that goes onto satellites, and he's worked on various projects from the Galileo satellites through to just little CubeSats that go up like 100 at a time. Mostly programming, but is moving into technical management now. I know people who've trained into medicine, radiology, so you can do conversion courses to become a medical physicist. And of course, you can get into food science as well. It's a bit off the wall there. My friend Amy works in food science at M&S. As you can see, that's just people that I know. The diversity and the options available are massive. And if you have an open mind and you know where to look, you could find anything. I think we should just look at kind of the value as well. Now, these statistics are regularly updated. These are 2 years old now. The financial value of a STEM degree is significant, and it will affect your earnings for your entire life. So other than those highly specialised careers like medicine, dentistry, like law, other than those where you might go and train with that in mind, the next highest is engineering, chemistry and physics. And what this graph shows, it shows you the percentage increase on someone who does not have a degree qualification. So if you get a degree in, say, history, you will still earn on average 13% more than someone who doesn't have a degree. But if you get a degree in physics, chemistry, engineering, I think mathematics can be included in there, you can be earning 30% more than someone who does not have a degree. Perhaps even 15% higher than if you studied a BA in English. And this is being put to the test right now at the moment as well, but I genuinely believe if you're prepared to move around and you're prepared to try new things, there will never ever be a shortage of jobs for physics or numer grads, ever. And I kind of will back myself on that even now. There certainly will never ever be a shortage of those jobs in teaching. Consider it. So when I talk about higher education options in physics, what do I mean? Well, here is a list in kind of order of most common to least common of things that students do after they leave Sir John Deans. Bearing in mind we send off about 120 students a year from physics and electronics. These are the things that they do, and I think these are the options that are available to you. Most students, and we're talking 90-95%, will go off to do a university degree. Might be a bachelor's degree, might be a master's degree. I'll talk more about the difference between those two things later on. Some go on to do a degree apprenticeship, so probably 3 or 4% will get an opportunity to go and work with an employer and work towards a degree at the same time. Semi-on at work, semi-on at university, so it's split between, you do a part-time degree. It takes longer than the academic degree, but again, it's kind of on-the-job training. You get paid throughout the degree apprenticeship, which is a really positive thing. I'm a big fan of degree apprenticeships as a kind of intermediate between just doing a job and doing a degree. I think if I was going through the system again, I would definitely have my eye on these. If you have a specific profession in mind or a specific employer in mind, degree apprenticeships are a really good option. If you don't like the idea of having large final exams and want to do kind of slightly more distance learning, slightly more coursework based practical stuff, degree apprenticeship is a good option. But we'll look more into the structure of a degree course later, and I'll try and contrast that with what you might do on a degree apprenticeship. You could just do a regular apprenticeship. Now, I think in the last 2 years, I don't know many people who've gone on just to do an apprenticeship that's not a degree apprenticeship. I think pretty much everyone from SJD who's gone on to do some kind of work has done a degree apprenticeship. But regular apprenticeships do exist. They don't get you the qualification, but you do get the vocational work experience there. And again, it's paid as well. Usually not paid as well, or doesn't have the same benefits as a degree apprenticeship. Usually this leads to a different kind of employment outcome as well. But it is a valid option, and if you find something that you really like and the apprenticeship route is for you, then we'll absolutely support you to get there. Another very common option, now I put this towards the bottom because it's not really an education option necessarily, but it's a perfectly valid thing to do. You might want to take a gap year. Students take them for all kinds of reasons. You might want to travel, you might want some time out, you might want to figure yourself out, you might want to do some work and then go back to uni. Now, there's two ways that you could take a gap year. You could apply through UCAS now, get your offers, and then defer them. That means that you get your offers whilst you're in year 13, you go through UCAS whilst you're in college, but then you don't take up your place until the following year. Okay, that is a way that I would recommend doing it, because then you've got all of our support. You know what you're going to do afterwards. Alternatively, you could not do that and apply in the next UCAS cycle as an independent candidate. But bear in mind, whilst I would be more than happy, if you got in touch next year and said, Rob, could you write me another reference? I'd be like, yeah, fine. You wouldn't have the same progress mentor support, you wouldn't have the same college getting you to do your UCAS application. If you're interested in taking a gap year, I highly recommend filling in your UCAS application now. And if you change your mind where you want a gap year, hey, you can change it, but at least you've got some kind of offer and some kind of security. If you change your mind, you can change it, but I think most people will just take the year out and then go on to do what they plan to do anyway. It's a really, really valid option, and you can just do it in between. I think it's one of the best times to take a gap year because no one's going to ask any questions. But then again, you need money to do it, and if you don't have any money right now, that's an issue as well. As 95% of our students go on to do degree courses and the most of the rest go on to do degree apprenticeships, I'm going to focus on what a degree looks like. What is a degree? So I'm going to use physics as an example because it's what I know, but engineering is usually very similar. You just kind of replace the physicsy topics like astro and quantum with engineering topics like dynamics and electrodynamics and stuff like that. So let's have a look at the structure of a physics degree and also look at the difference between a master's and bachelor's, look at single honours and combined honours. So there is a vast variety of courses to choose from, and they all feature little buzzwords in their title and all that stuff. So how do you know which one to choose? Basically, have a look at the courses. Don't just read the title and think it sounds cool. Go onto that course website and read how it's structured. What modules will you be studying? Will you be doing maths in the background, or is it integrated with your physics? How much labs will you be doing? How much time do you spend on a specialism? All of these are things to research for yourself. But I'll outline a couple of little things. Now, you might just do a degree in physics, just pure and simple. I know a lot of people that graduated with me just have BSc or MSc physics, and that is fine. But you might choose to do physics with a specialism, or you might choose to do physics and a specialism. And that little word in the middle makes all the difference. Is it a with or is it an and? Because that tells you a little something. So usually physics with comes with a physics-based specialism. So if you have a look at this list, there are loads, and you go out there and research courses, you'll find all of these. You can do physics with astro, with business, with engineering, with language, with theoretical physics, with study abroad, with a year in work, with computing, with a professional year. You can do physics with anything. These are what we would call single honours courses because they're mostly based in physics, but you have that extra little specialism to describe which part of physics you focused on. You will do an ordinary physics degree, but maybe a couple of your modules each year, rather than being further maths or further physics, maybe if you do physics with astrophysics, that'll be where you do your astro labs. Maybe that'll be where you do your engineering modules. Maybe you'll have a language slot instead. It all takes up the same amount of time, so you just swap out maybe an additional physics module for that specialism in astrophysics or that specialism in maths. They're really well connected together As part of my degree course, I did physics in my second year, and I also took Stars and Galaxies astrophysics module as one of my optionals, and it slotted together really well and helped to reinforce the stuff that I was learning in core physics. In my opinion, it's much of a muchness which one you choose. You will still do the same amount of physics, you might just have a slightly different specialism. The other word that you might read is physics and what comes after the and tends to be a whole other subject. So you might do physics and maths, physics and astronomy, physics and philosophy, maybe even physics and chemistry. This is what's called a joint honours degree. So if you see the term joint honours, that means that you do physics, but you also do the other subject as well, complementary to that. So for example, when I first went to university, I signed up to do physics and chemistry. So 2/3 of my degree was physics and 2/3 of my degree was chemistry. And I know what you're thinking he's made a mistake there because that doesn't add up to one. That's because a combined honours generally features a bit more work than a single honours degree. It's usually an extra third or an extra bit because you have to squeeze together these two subjects. I actually had more contact hours in my first year of physics and chemistry than anyone else that I knew. So I was definitely getting my money's worth, but it was also very, very hard to balance that time. I've always been quite a busy person. I changed away from physics and chemistry because chemistry is boring, and I took up climate geography and did some climate science because that linked into climate astrophysics and stuff, which I found really, really cool. Did some politics as well, did some governance because all of that is interlinked with the climate, and I ended up with a BSc in natural sciences, physics and geography. It tells you that, yes, I did core physics, but I also did that complementary subject of geography, and not only was it 2/3 physics, it was also 2/3 geography. As I say though, think about what you want to do. If you love physics, you'd probably be fine just doing a physics degree or maybe a physics with astro. If you have that specialism that you really want to learn about, quantum or theoretical or maths, then take the with option. If you're torn between two subjects, joint honours degrees do exist and can be a great way to combine those two things that you like. Whatever you choose, don't feel like you're setting your future in stone. As I say, these degrees are super broad in scope and equip you with a huge variety of skills which we'll explore later to enhance your appeal to future employers. I've mentioned a little bit masters, bachelors. What's the difference between those two things? You might not have heard about this before. A bachelor's degree is a 3-year course. If you pass each subsequent year, you make it to the next one, and then at the end your scores are added up in some way, which is different depending on every university, but whatever you get on the outcome of those 3 years, you graduate with a BSc in whatever subject you've picked. Bachelor's is the B, and you get a Bachelor of Science degree regardless of what subject you pick. So I have a BSc Natural Sciences because I did 3 years. The other option is what they call an integrated masters, or just a masters anyway, and that will be an M for masters, and then you get your subject after that. So you might get an M Phys, you might get an M Eng, you might get a M Math or an M Phil. Yeah, all of those degree courses are at masters level. They take longer because that extra year contains a large amount of independent research. It's just an extra step up. So if you want to be an academic, if you want to enhance your employability and show that you have that additional level of independent skill, get a master's course. For most people studying engineering, the kind of industry standard, if you want to go on to be an engineer, is an M-Eng. So it's very, very rare that you'll get an engineer with a bachelor's degree. Most engineers nowadays will graduate with a master's and then go straight into work. You can do conversion courses in that 4th year. So for example, I don't have a master's degree. If I wanted to go and retrain as an engineer, I could choose an engineering master's degree and be an M-Eng as well. And that would be Rob Fowler, BSc, M-Eng. Likewise, if you had done 3 years of a maths degree, but you wanted to specialise in a better subject, you could go and do a master's in applied maths or in physics, and you could be a BSc in maths, but a MPhys. So you can chop and choose, or you can just choose the 4 years up front. The Masters usually comes with this really big research report as well. Don't be afraid of that, because it will be on something that you hopefully find really interesting or quite enjoy. At this stage, you might not have thought that the work that you're doing on your degree is work that you'll really enjoy and love, so that extra year isn't necessarily a bad thing. I thought I'd take a minute to think about what people do on a physics course. Loads of people say, Rob, what do you actually do day to day? And so these next couple of slides are going to look at that. And I know they're a bit big and a bit messy, but I was just trying to fit it all on one page. Have a look. Typically, physics or engineering, chemistry, whatever, any university course will have core modules. Those are things that are compulsory. So if you're doing physics, you will have to do a core module in mechanics, in thermodynamics, in quantum, all of those key areas of physics that you need, because without them you wouldn't be able to understand anything else. Usually on a physics and engineering degree, one of your core modules will be in maths. You need to know how to do some quite hard maths. They usually have 2 or 3 lectures per week, and those will come with most of your weekly problems and exercises as well. They might be examined in different ways, but again, that depends where you go. You also have these elective modules. I talked about them a little bit before. This is where your with options come in. So if you wanted to go and do physics with German, you might take an elective module in German. You might take an elective module in computer science or in astro. Those are your options. They supplement your degree and make you into the rounded, interesting person that you are. It might actually change your degree title. For example, I did not know that I was going to get physics and geography when I started my degree. It was because of the optional modules that I took that influenced my final outcome. On any physics or engineering course, you'll have a weekly lab, sometimes bi-weekly, and usually that's a whole afternoon or sometimes even a whole day session in the lab. And it's usually a slightly different project each week or each fortnight. Sometimes they might run on for a month or so, and usually that will come up with a full write-up for the experiment as well. So you'll usually be investigating something and then writing up a lab report about it. You'll have a lab book, there'll be health and safety stuff that you need to adhere to. It's a massive step up from the practicals that we do here into the kind of practical that you would do as a research physicist. It's really, really important. If you're doing engineering, I'll talk about the difference between physics and engineering labs a little bit later. You will also have problem-solving workshops, sometimes you might even have tutorials, and they're the small group sessions. That's like when we say, I'm going to shut up now, you do the problems. It's the same kind of session here. You will kind of have these workshops where you do problems and you can speak to doctors or professors, tutorials where you might actually get to know an academic and spend some time with them. And you can just ask questions, they might even have some kind of discussion going on. They're all part of the stuff that you might experience alongside these big lectures that you have. To give you an idea of what this looks like, this was my timetable from when I was doing my degree. You'll notice, probably a bit like your college timetable, there are big gaps in it, and there are times when you're very busy. For a physicist or engineer or mathematician, you should expect to be doing a kind of 9 till 5 day. And as you can see there, on most days, my lectures were at 9 o'clock in the morning through till 5. You can expect lots of hours of contact. If you're doing an arts degree, you might have 1 lecture a week per subject, whereas if you're doing physics or maths, you probably have 3 lectures a week per module. So you get a lot more time with your teachers, or a lot more time in that kind of lecture environment. But you've got to bear in mind that when you're in a lecture, you are not doing work. When you're in a lecture, you're listening. You're not necessarily practicing. And that can be quite jarring for some people when you go to university. You sit there for 40 minutes, for an hour and a half, and you learn about the physics. You get told what's going on, but you can't practice doing it in a lecture. So although this is the timetable and it's got lots of gaps in, just like at SJD, expect to be doing a lot of work around that at home, during the day. Maybe you'll go into the library, maybe you'll organise yourself into little groups and have study sessions as well. I expect to be doing quite a lot of work. And when I say quite a lot, I mean like a lot of work. Here's some of the stuff that I wrote. These are my revision posters I used to write on my wall on my window. You do work very hard. The kind of trade-off that you get for this really, really secure job or this employability, these degrees are challenging in the same way that studying maths and physics at SJD is challenging, but hopefully you'll actually really enjoy them as well. You know, it's interesting work, or it should be. It pays off in the end because you learn about all this interesting stuff and you can just carry that with you for the rest of your life. You know, I can solve second order differential equations because I learned them on my degree, and it's a really interesting skill to have. I know that a lot of people can't do it, and that's what makes physicists employable is things like that. But don't fear. I don't want you to think that it's all hard slog, because going to university and studying, even if you're on a degree apprenticeship, the social aspect is the kind of big part. You, for the first time, are living with people. You learn how to do things like wash up, take the bins out, that kind of thing. It's very, very different to what you have now. You meet people who are your age. Most of my best mates that I have now come from university. Things like Freshers Week is a great opportunity. You go to fairs, there's special nights where you meet people. You might get involved with societies and sports, and I would absolutely encourage you to do that. You know, I took up like basketball, jiu-jitsu. When I was at university, I worked for St John Ambulance, and that looked great as kind of work experience and stuff. You can volunteer, much like in college, but on a whole new level. You know, someone in the year below that we were looking after on a pastoral level ended up becoming a University League Quidditch superstar. They're amazing at Quidditch. For example, ultimate frisbee and things like that. Try them, these sports. They're fantastic. And this is the only opportunity you'll get, by the way. When you're an adult, it's much, much harder to kind of take up new things in the same way. You might be interested in music, in drama, theatre, films, whatever. There's that cultural side to uni as well. You might get to do trips, like ski trips, or maybe visits to certain places. You might get to do years abroad. Sometimes you might get to do research that's funded by the university abroad as well. And there's just random things that go on, and I think that was one of my favourite parts of uni, is just you'd be walking around one day, you'd run into someone that you know, you'd go and have a coffee, and then you'd end up kind of saying, oh yeah, we should do this, that or the other. Like just random events. And even, you know, there's one in the middle here. This is a charity thing that I took part in called Formerly Lost. We had to turn up like 6 a.m, put a blindfold on, we got on a coach, and we drove for 3 hours and we dropped off in the middle of nowhere. Nobody knew where we were, and we had to get back to Durham in time for a black tie dinner in the evening, collecting charity money all along the way. It was a one-off, it was completely random, and it's little random things like that you will have no idea about right now. I just wanted to share they do happen, and they're some of the best memories that you'll have of your time at university. So I'm going to slowly round off here with the big question that people tend to ask. What is the difference between physics and engineering? Which one should I do? I can't answer the second question because that's down to you, but I can tell you the difference. If you study physics, it's likely that your optional modules will contain further physics, so like quantum, astro, particle, whatever. And it's generally more academic and generalist. It'll lead to the whole variety of career options. You're keeping your options open. You can go on to study further things in physics as well afterwards. If you do labs, they're generally kind of research and experiment based, trying to maybe prove a law or deduce something or maybe find something out. There's not usually any focus on professional skills. It's usually academic physicsy skills. It does contain very hard maths. You will probably have optional modules in maths, and the best thing about doing a physics degree is that if at the end of it all you choose that you want to be an engineer, there's no stress, because physics is engineering. Engineering is just a branch of physics. You just transfer. And I've already spoken to a few people about this already this year, but if you look at postgraduate courses, not undergrad, postgraduate courses, log on to, say, Manchester University, their website. Rather than clicking on the undergraduate tab, click on the postgraduate tab and look at the courses that exist there, and you will find 1-year MSc or MEng conversion courses for a variety of different things. It's dead easy to do. On the flip side, let's look at engineering. Now, engineering does not cover things like quantum physics, funnily enough. Engineering covers things like mechanics, you're building stuff, you're making stuff work, thermodynamics, how do engines work, what about Carnot cycles, how fridges work, how heat pumps work, You do a lot of electronics as well. You might study the whole systems approach as well, and integrated systems, looking at how products are made, product life cycle. It's generally focused on engineering as the target job with your given specialism. If you do engineering, your labs will still include some element of experimentation, but quite often it will be kind of designing and testing. It might be experimenting on an idea that you've looked at in a kind of a targeted way. It very much depends where you go and what they focus on. Some engineering courses will have electives or options where you can develop your business skills. So some will have a management elective, some might have a people skills elective. Because engineering degrees want you to go on to be an engineer and get employed there, some, not all, will have a professional skills element as well. One thing I can't stress enough is that physics degrees contain equally hard maths to engineering. Engineering degrees are the same as physics in terms of maths. Don't think that choosing engineering is the soft option. It just isn't the case. You still have a core module in maths when you study engineering. So you will still have to study calculus, you will still have to study vector algebra, dynamics, you have to know what a Jacobian is and how matrices work. You have to do all of that, otherwise you're not really studying modern engineering. It contains equally hard maths to physics, bear that in mind. And another thing that I tend to find is that people who do engineering courses, there's not so many back conversions into physics. So for example, if you've done an engineering degree, you might not have studied quantum physics. And if you were to go and try and do a master's degree or a conversion course into physics that relied on some maybe quantum harmonic oscillators, you would suddenly feel very out of your depth. It's not impossible, but I've not really found one where you can go from engineering to physics seamlessly. It's very easy to do going physics to engineering because they're one and the same. Everything that you learn in physics is applicable to engineering. But in engineering, because it's focused on things that engineers use, like mechanics, thermodynamics, because you don't have astro or you don't have quantum, it's harder to go the other way from engineering to physics. Although that said, the same career options will be available to you anyway, so I wouldn't worry. Unless you wanted to go and do a PhD, I wouldn't worry about the career options difference. I think the same options are largely available to engineers and physicists, provided that you're really good. And here's a little comparison of the career areas that you might go into. They're largely very similar, except the top of engineering is engineering industries. That shouldn't really be a surprise. Physics is one of those slightly more abstract ideas. People say, what do physicists do? Well, that's because there isn't really a job role of a physicist. There's a job role is, a designer, construct tester, whatever. You might go and work in aerospace and defence, research, programming. Data modelling is a big and growing area of employment for physicists. Consultancy, technology. Actually, one of the biggest areas is the financial services. A lot of physicists will go and work for investment banks, for actuarial, for accountancy, consultancy, those kind of things. Financial services is a massive employer area for physics. I think it's something like 22% thereabouts of physics graduates. So about 1 in 5 physics graduates go to work in the financial sector. And that is actually makes it one of the largest areas of employment for physics grads. As I said at the beginning, if you want to go work in finance, don't do a finance degree, do a maths, physics or engineering degree. And you will actually be better at all those core skills. You'll be more employable and you'll have better job prospects, I would argue, than if you just did a finance degree. You might have to learn some stuff that you didn't know already, but that's no issue. If you can do quantum physics, you can do accounting. Engineering is largely the same, but your job title will probably have engineer in front of it. Doesn't mean that you can't go on to do all those other things. I know engineers that are now bankers. It's just the way that, it's just what you can do. Those options will always be there. So pick and choose. People say, what are the best universities? Well, these change year on year. There's a really good website called whichuniversity.com, which I think might have just changed to gooduniguide.com. They rank things in terms of student satisfaction and all of that. The key thing that you should ask when you're choosing university is, do I like it here? Okay, because it doesn't matter how good the university is, right? If you apply to Oxford but you don't like the vibe, you're going to have a bad time. You've got to go to university that you like. And I think that's the simplest advice I can give. I'm sure that you can find one. I went to Durham because I love the Northeast and I love the people, thought it was a really pretty place. But I think I would also have liked Manchester because I like the vibe, or Liverpool, But I wouldn't have liked it down south. I don't really like London. You get those black fingernails. I just didn't get the right vibe from there, so I stayed up north. You've got to go somewhere that you like. So look up the league table if you're bothered about that. But most importantly, go somewhere that you like. Always have an insurance choice as well, just in case things change in the future. I thought I would just close with some thoughts from the literature. Now, some of the data that I used in this presentation came from actual government statistics. It came from the Institute of Physics as well. The government and all of these places really, really hold STEM grads in high regard. You can see that quote there. Graduates in STEM are widely recognised as critical to the UK economy. But there are other interesting things which I think are relevant to you. So, for example, most students that chose STEM chose it because of personal interest and enjoyment. Don't forget that. Job prospects won't matter if you really don't like those 3 years. Just think about it that way. You've got to enjoy what you're studying. So, a degree might have the best job prospects in the world, but if you don't actually enjoy that degree, you're not going to make it. And those job prospects will mean nothing if you don't graduate, with a decent degree outcome. I think you've got to really enjoy, be interested in what you study, at least somewhat, and you've got to like the place that you go. Employment opportunities should be a less significant factor, as it says here, and that is common. Backed up there, relatively few STEM students chose their graduate course with a specific subject in mind. The individual career paths of STEM graduates are not simple and not always predictable. This comes back to that original point, guys. You can do what you like. If you are a really good physicist or engineer, go be a wildlife photographer. Why not? If you're a really good physicist or engineer and you enjoy helping out people, why not go work in freshwater? You're bored of defence now, why don't you go and work in telecommunications, right? You can just hop and choose because those skills are so broad, and because we know you have a physics degree, you're clearly able to learn stuff quickly. Irrespective of the employment sector, most make good use of their broader graduate skills in their current jobs, because you have loads of them. And a very high percentage of STEM graduates become business and finance professionals instead of pursuing a career in science. This is what I was saying before. Nearly 20% of all physicists choose this option. This is indicative of the correlation between the skills developed while studying science and the skills required for success in business-related sectors. It's just so that I can show you here, it's not just me saying it. This is from the government, it's from HECSU, which is a body regulating and monitoring this kind of thing. All of these are from external sources, just saying the same kind of thing. I'm not saying it to encourage you. This is genuinely real life when you're a physics or engineering student. So I thought I'd end on those quotes. I hope that's been interesting and useful. I know it's quite long, but there's a lot to talk about. And if you have any questions about anything, do just get in touch. We send off probably 120 students every year, don't forget that. Most of our students get exactly where they want to go, and slowly but surely they filter through into their chosen career areas as well. And it's always so interesting to hear those stories. There are so many absolutely brilliant ones. I'm sure you'll be next in line.